there. Welcome to the another video of software engineering. In this, we are going to see again Unit 2. We are now starting Chapter 2. Before that, we were covering Chapter 1. Let me make it my screen big. We are going for Chapter 2. In this, we are going to see something about building of analyze model. What is analyze model, requirement analyzing, and data modeling concept. These three things which we are going to see. Okay, uh, we are going to start. This is the part of software engineering unit 2. Now, what is goal of analyze model? What is an analyze model? Provide the first technical representation of the system. What is the goal of analyze model? Provide a technical representation of the system. That is what is functional requirement, what is not functional requirements. All this detail deals with the problem of the size of division, means break down the modules or break down the project into parts and explain them what are each part look like. It differentiate between essential information versus implementation, what system has to do it, how system has been implemented, what system has to do it, and how it is implemented. Help the keep track of evolution and what is tracking of how the project is evolution and how it is going to interface with the other one. So the basic part of analyzing model is nothing but it first represents a technical representation. It divides functional and non-functional requirement, deals with problem size, means it break down into parts, differentiate between what system has done and how it is implemented. Now, requirement analysis. Requirement analysis specify software operation characters, how software is operated in different conditions. What are the different conditions? Means what are the inputs you are going, what are the outputs you are going, and where we are going to use, how we are going to use. Indicate software interact with other system elements, like when you are interacting with the web servers, like you are interacting with any API outside services, how your system or your software interact with it. Establish constraint that system must have. Means what are the constraint, what are the limitation of your software, what are the limitation of your hardware, has to be explained properly in this one. So do remember, requirement analysis specify what requirement operation is, what are the condition of this, how software interact means with the outside world, like we have web services, another one. What are the constraints? A requirement analysis allow the software engineering work called as analytic model. It is also called as an analytic model. It elaborate the basic requirement established during early requirement. Analytic model, analytic engineer, what it will do is that it elaborate the requirement, what it has taken from the initial state. Create a model that how the user interact with the system, the task needed to be done, the problem, the categorize problem, and how they are related to each other, how the system classes are, how the data move when the input is given, is described in all this analytical model. Okay, so create a model that how the user interact with the system, the tasks that are needed to be done, problem categorize, how they are related to each other, how the system and the class act to each other, how they moved, and how they are changed. Provide the software design with represented with a representation of information and behavior system. This later translate into architecture, interface, class development, and everything. So what is the information and how it is behave in this one? Correct. The next part, it acts like a bridge between your system description and design model. Analytic model act as a bridge between both. What is the system description? You modify, you made into model, then how you are based on this one, you're going to design it. It applied between what hardware and software, how the data looks between hardware and software. What software design describe the software design architecture, use interface, what are the interface you are using, what are the component level, and everything has to be done. What is the hardware level, what are the hardware you are going to use, what are the system overall system configuration has to be mentioned in this one. Correct. Overall objective, three main objective of it: to describe what the customer required, what is the customer to establish basis, to establish the basis of creation of software, what the customer required. On this basis, we are going to design a system. to define a set of requirements that can be validated when the software is built. Once the software is built, we are going to verify that to describe what the customer required based to establish the basic of creation of software design. To establish this one, we are focusing on what rather than how we are going to do it, what we have to do it rather than how we are going to, what is a functional performance and what behavior has to be done, what has to be done later part, how it is done, it's in this part. Correct. Design model, how it is done, it comes here, what has to be done comes here. Correct. So this is performance and analyze thumb rule. You need to follow a thumb rule. The analyze model should focus on requirements that are visible, means that are actually needed for the customer or for the stakeholder for the business environment. We are not going to elaborate all the things which are visible. We are going to do it. The level of abstraction should be very high, means point to point. What are their very important point? Each element should analyze model should be added to overall understanding of the project. Information about the function, behavior of the system, all this should be added in overall understanding of the software requirement. The model should delay, means as what should be that, such as performance, scalability should not be mentioned initially in the design phase. First phase, it should not be phase. What is the performance, scalability, and everything that makes the stakeholder very nervous in that one. So that model should delay the consist of infrastructure, that is non-functional requirement should not be mentioned in this one. The model should minimize the coupling, means depending on other systems, depending on other modules. So you have to more independent on that. The model should provide value for the same. All points are to be met. The model should be very simple. Thumb rule is this one. Correct. Abstract level, very high level, and overall understanding of the project. Non-functional requirements should not be mentioned. Minimize the coupling. Independent models. Models should provide each point, each requirement should be provide value to the stakeholder. It should be very simple. Now, domain analysis. Software domain analysis is to identify, analyze, and specify for common requirement for specification for domain for technical use, which is done by Donald Smith. Which phase this word means it is used for reuse purposes. Domain analysis maximal pass for reuse, which is done by this Donald Smith. Now let's move. Domain analysis. Input source. Technical literature that provide documentation of current software and what are the methods used. Existing application. What are they? What is there? What is not there? What is the customer feedback? What are current features and everything? What are the output? Class taxonomy. What do you mean hierarchical of class, subclass, structure, representation? Everything is there. Reusable. Coding pattern should be used. Functional dependency. How system responds to a different input and output should be mentioned. Domain language. So what are input? Domain analysis, what is a technical issue, what provided, what is an existing system, what is not there, what is the customer feedback, what is the feature you have to add it, what is a hierarchy of it class, what is a reusable, what pattern what coding we are going to reuse, functional behavior, how the system responds to different input and output. Domain languages. Define the domain. Define the domain to be investigated. Define the domain to be investigated. What is that? What is the area of interest that you need to investigate? Collect a representative sample for application of the domain. In the next step, what we are going to do, we gather whatever the domain we are interested, we gather all this information from the existing system for that domain. Collect, next gather the set of existing operation within that domain, means we are going to collect all the information of that domain. We need to apply then how each function works. Then based on that one, we are going to develop a new model which can be reused, modifying that, using that part, reusing that part and modifying it for requirement. Define what is your domain interest, collect the sample of that domain, analyze the model, how the function required, develop analyzing based on what we have gone through it. Correct. Now analyzing model approach, there are few things which is there. Structure analyzing, consider data that process transformation of data from separate state, means we have Consider the data and the process that transfer the data into separate entity. Data in a model in terms of we have to specify only attributes and relation, not what are ER diagram. What is entity? We are not bothered. What is its attributes and its relation means what are the input data, what will be the output data. That is what we are not bothered. What is an entity? We are not going to see. We are only bothered about what is only attributes and relationship. We are bothered only attributes and relationship. We are not bothered about entity and what will be the input and what will be the transfer occur when certain data is given. How the result of the when there is an input, this is our data. If there is input, what will be the output for this one? Correct. What will be the resultant output of that object oriented analysis is given. So this is what a structural model. We are not bothered about what is entities approach and everything. We are going to give you the concept of attributes and relationship. What is the input, what is the output when some data is going. Correct. Now element of analyzing model, object oriented analysis, scenario based modeling, use case diagram, activity diagram, swim line diagram, flow oriented model, data flow diagram, control flow diagram, process netting, class based diagram. We are going to see all this in unit 4. At the moment, the element of analyzing model is we can see object oriented model or structural analysis. In object oriented model, we have got scenario based modeling, class based modeling, behavior modeling. In structural modeling, we got flow modeling. These are the parts which you use in this one. Data modeling. The other part, examine the data object independently. Look in what data is needed, what's its attribute, what are its structure. Create a model based on the requirement. What is an object? We are going to see later. Object is a real thing which is represented or stored in somewhere on your system, just like your entity, but it is stored in a system. Create a model based on customer level abstraction. Indicate how data object is related to each other. Look for what data is needed, its attribute, structure, separate in specific file to ensure that model is not only technically accurate but also understand relevance, means how the model is related to each other. Might include how in a table format how they are related. The software development, I just told you, the data model is a data object group of data field that often thought to be a real world, like student or manager or workplace. This is an object. What are its attributes? We are going to see. The data object is actually a location or region of store that contain collection of attributes or group of values that act and accept characteristic, quality, and other things, which is stored at some place and it's going to act on it. A vehicle of data object which can able to identify, describe the set of attributes. Example is here. What are typical object are external entities, that is printer, user, sensor, things, reporter, display, signal, occurrence, interrupt, and alarm. Role, what is the manager, engineering, salesperson, organization, division, team, manufacturing, floor, and everything. Here, object. This is automobile engineering and different part of it. Correct. This is automobile engineering, and these are its attributes. What is the make? What is the model? What is the body type? What is the prints and everything? The data object contains set of attributes which are specified. This we call it as data object, and it is stored. That is totally different. Okay. Now, relationship. What is the relationship between? What are connected lists? Several instance related. What is called a relationship? I'll just go in a part. How they are related to each other. Correct. Objects are related in many different ways. There are cardinal. That is one to one. Sorry, I'll write here. One to one to many to one, many to many. Okay, or one to one to n, or n to n. This is our cardinal relation, which is here occur. Specify the number of occurrence of one object can be related to occurrence of other object. This is cardinal relationship. It is represented 0. There are no involved. 1. They are occur in one relation. Here, entity relationship. I just told you one object and it's related to